Today we're talking about the laws of exponents. We're going to look at exponents in a way that we've never done before. And we're actually going to manipulate the exponents themselves instead of figuring out what the exponents mean. The first rule, there's actually 3 rules we're going to do today. The first rule is called the product rule, and it tells us that when we have like numbers or variables with exponents that are multiplied, that we actually should take the exponents and we should add them. So an example would be if we had n to the second power times n to the 5th power, that would actually equal n to the 7th power, because we would take our exponents 2 and 5 and we would add them together. The second rule we're going to talk about is the quotient rule. The quotient rule is almost identical to the product rule. Let's look at it. The only words that are different are the words multiplied gets switched to divided, and the word added gets switched to subtracted. So when we have like numbers or variables with exponents that are divided, the exponents get subtracted. So if we had n to the 5th power divided by n to the 1st power, we'd take our exponents 5 and 1 and we'd subtract them and get n to the 4th power. The last rule we're going to talk about is the power rule. The power rule sounds complicated, but it really isn't. When you have a number or variable that has an exponent with it, and it's raised to a power, so in other words, you have a power to a power or an exponent to an exponent, then you multiply the exponents together. So if you'd have n to the 2nd power to the 5th power, then we would take the 2 exponents, 2 and 5, and we'd multiply them to get n to the 10th power. That's how these work. Let's look at a few examples. The first few examples use the product rule. So if we have 12 to the 4th power and 12 to the 2nd power, we put those together. Our product rule tells us that we add our exponents. 4 plus 2 equals 6. So we'll get 12 to the 6th power. Okay, let's do one more like that. If we have 3 to the 8th power and 3 to the 5th power, again, we need to add our exponents. So we'll get 3. 8 plus 5 is 13, so we'll have 3 to the 13th power. And the third one, if we have x to the 21st power times x to the 7th power, we keep our x, we add our exponents. 21 plus 7 is 28. Okay, our next set of examples uses the quotient rule. Now the quotient rule, if you remember, tells us that we need to subtract our exponents. If we're looking at a division problem, we need to subtract the exponents. So 5 to the 8th power divided by 5 to the 2nd power. We keep our 5, that's our base, and we look at our exponents, 8 and 2, and we subtract them. 8 minus 2 is 6. So we have 5 to the 6th power. The next one, of 3 to the 11th power divided by 3 to the 0 power. We look at this one. We know we keep 3 as our base, and then we take 11 minus 0 equals 11. Okay, and the last one here, r to the 20th power divided by r to the 10th power. We keep r as our base, and we subtract 20 minus 10, and we get 10, so our answer is r to the 10th power. Now here's our last group, and they're going to use the power rule. The power rule tells us that we take the exponents and we multiply them. So if we have 2 to the 6th power to the 8th power, we keep 2 as our base, and then we multiply. 6 times 8 equals 48, so our answer is 2 to the 48th power. Let's look at the next one. We keep 5 as our base, we take our exponents, 2 and 10, and we multiply them. 2 times 10 is 20, so our answer is 5 to the 20th power. And our last example, n to the 4th power to the 4th power again would equal n as our base, we have to keep that, and then multiply 4 times 4 to get 16 as